Are you planning on setting up a 12-volt solar application? Here are 2 kVA hybrid inverters. This is a Sako hybrid inverter, looking bigger and in a beautiful case. This is a Powmr 2 kVA inverter, just in a regular carton case. So we will be testing their inverter abilities to see how powerful they can get, and also testing their mppt charging abilities. Also, I have a standalone mppt charge controller from Most right here. So we will be testing how well the hybrid inverters charge their batteries in relative to how a standalone mppt charge controller charges a battery. So first, let's do the unboxing of the inverters and see their ratings. Inverter capacity 2 kVA, 1600 watts, power factor 0.8, DC input 12 volts, 133.3 amps, the solar charge mode 2000 watts, same thing for the both of them. You have the mppt range 45 volts to 400 volts for the Sako, while for the Powmr you have mppt range of 30 to 400 volts. I think that's a little bit different for the both of them. Then the Sako inverter is a bit bigger than the Powmr inverter. So now the 2 kVA Powmr hybrid inverter is connected to a 4 kWh battery. So we'll be testing with this 30-liter microwave. It is rated 1400 watts. Let's see how powerful this 2 kVA hybrid inverter can get. So we'll put it on. The fan is pretty loud. Wow. 30 minutes. Wow, see it powering it without stress. Powering it without stress. 135 amps. 135 amps, 1.3 kilowatts. 1.3 kilowatts. 134 amps. And you see, without stress, this battery combining with this inverter is a bomb for a 12-volt solar application. Wow. Can you see? 4 kWh battery with the 2 kVA Powmr inverter. And you see this 133 amps going down. See. And you see this. And you see this. The microwave is working. The microwave is working. It's working. 132 amps continuous discharge. Wow, this is amazing. This is amazing. 4 kWh battery. Wow. Okay. Okay, so now let's test the Sako with the same microwave inverter and see if it can power without stress. Now it's time to test how powerful the 2 kVA Sako hybrid inverter can get. It is connected to a 4 kilowatt hour battery. So let's power it on now. So let's power the microwave and see. Power and see. Let's go for 2 minutes. Okay. Okay. Let's see. Sako is powering it 152 amps. 1.29 kilowatts. Okay. Wow. The microwave is working. The microwave is working. Can you see? This is a 30-liter microwave. Rated input 1.4 kilowatts. This is a 4 kilowatt hour lithium battery. A Sako 2 kVA hybrid inverter. Can you imagine what we are powering right now? You see this? See the battery? See the load? This is amazing. This is amazing. Can you see? The battery is powering. The inverter is doing a nice job. Can you see this? 131 amps on the battery. So now let's test their charging abilities. So now I have connected a 535 watts Sako bifacial solar panel to this system. Let's see the charging rate. What you are getting right now is 370 something watts from the solar panels. The system is currently on, charging at 370 watts. As input from the PV. Currently charging the battery at 17 to 18 amp. Okay. Currently there is no load connected to this inverter. No load connected to the inverter. We are only testing the charging capability right now. And the max we are getting is about 370 to 380 watts. Now let's test the charging of the other inverter. Now the Powmr is connected. Let's on and see. Let's see the charging power. This guy is charging beyond 400 watts. It cannot go beyond 444. Now this is a standalone mppt charge controller, and it is charging similar to the Powmr hybrid inverter. 0.41 kilowatts, which is about 410 watts, very similar to the Powmr hybrid inverter. Now I'm wondering why Sako couldn't get up to 400 watts. I think we should try it again. Maybe the sun might have increased over time. So let's try the Sako and see if it will get up to 400 watts. The Powmr and the most mppt charge controller has given us over 400 watts. So let's try the Sako. Let's see how powerful it can get. We still cannot get over 380 watts. We're still stuck between 380 watts. So I was wondering why Sako couldn't give us over 400 watts like the other inverters. And then I remembered at the specification of the Sako, they stated that for best performance, you need to have a 120 to 400 volt DC coming from the solar panels. And we used just 2 panels for this test, which gave us a max of about 80 volts, which is now up to the requirement for best performance for the Sako, which is 120 volts. So if you are going for the Sako inverter, make sure you calculate your voltage to a 120 volts so you know how many panels you are buying. Thanks for watching.